fascinated by geometrical optics and camera lenses since his university years actually. His career started with Nikon in 1990 and then to Sony in 2003. Now he's a deputy general manager, a specialist in optics, and the world patent champion for optical design. Ladies and gentlemen, please put your hands together from Sony Japan, Mr. Motoyuki Otake.
Okay, first of all, thank you very much for coming today, and thank you very much for supporting us anytime. Okay, today I'd like to talk about new lenses for this spring. But before that, I'd like to introduce myself. Yes. Now, I have 3 faces. One of them is the optical designer. Yeah. She mentioned, as she mentioned, now I'm a patent champion in the world, and I have a lot of patents. But now, I also trainer for a young designer. So now, our new designer grow up. So yeah, my young designer will become good designer compared to me. Yeah. So I think that we will make a good lens in the future. Yes. And the manager. Thank you. Thank you. And the manager. Yeah. What to say? My motto is to motivate my colleague. Yes. Because motivation is very important to become a good designer and to design a good lens. So I think that, yeah, I always speak. Okay. So go on to the next page. Today's agenda, we will have 3 topics. First of all, our MTF curves. I'd like to explain the detail of the MTF curves. Next, planar twister 50mm f1.4. Yeah, this lens will release on May. And finally, I'd like to talk about the 70 to 400mm UG lens. Okay. Etc. Yeah. This is a bad image. Okay. And how do you feel this picture? Average. But compared to the next page, okay, can you feel the difference between the 2 images? The answer is contrast, difference in contrast. First image is like this. The next slide is here. So I think that the contrast is very important to create a good image. Okay. So I will explain the MTF curves. At first, what does mean 100? In the MTF curves, horizontal axis shows the distance from center of image, and the vertical axis shows the contrast. And the high contrast shows like this. Contrast between the black and white is very clear. In that case, the contrast is high. But in the low contrast, image between the black and white is unclear. So in this case, image becomes blurred, and unclear. Okay. Next, what does mean 10 and 13 line pairs millimeter? 10 millimeter shows the red line shows the 10 millimeter, and the is fine. 10 millimeter per 10 lines per excuse me, yeah. 10 lines there per millimeter shows enhanced impression. So, see, at first you can see the total of the image. In that case, the 10 lines per millimeter is good to enhance the impression. But 30 lines per millimeter to get the details. First of all, you will see the total after the detail of the image. So in that case, 30 millimeter is very important. So we will show the MTF graph in the catalog or website to show the performance like this. By the way, so there are a lot of lenses now, and sometimes MTF of 10 is high and MTF 30 is also high. 10 is high, but 30 is not high. 10 is not high, but 30 is high. Can you see the difference between among the three images? The left image shows the ideal lens. Center image is detail is not good, like this. But the impression is good. So this image is current lens. And light on is show the old lens because how to say this image is not clear. Okay. So in our new lens, we try to make it as like this. Okay. So can you understand the meaning of the MTF paths? Okay?
Yes.
Okay. So I will show you the new lens. This slide shows the specification of the 50mm lens. Focal lens in stock, and the lens configuration like this. And there are two aspects of lenses, not including the ED glass. And the minimum focus distance is 0.45. And the maximum magnification is 0.14. And focusing type is rear focusing. And the diameter is 72. And the size is like this. And the weight is shown here. Okay? And this slide shows the comparison chart between the competitors. And this one shows the current on our current 50mm f1.4. And these are the MTF paths. Okay? Upper line shows 10 lines per millimeter, and the lower shows 30 lines per millimeter. Okay? And we have to introduce the SSM motor. Okay? And we have two improvement points. One of them is here. Low frequency contrast is not good in the current model because when we design this lens, we like to improve the resolution, not contrast. So finally, the resolution is high, but contrast is not high. And also here, see the performance in the corner area is not good. Yeah, of course the competitor's lens is the same, but we'd like to make it good. Okay. Next slide shows the way to design new lens. So because I'd like to show you the difficulties to make the new lens. Okay. This is our current model. At first, we add the wide converter because, and in that case, the version is very well collected, but it's very difficult to make it in the mass production. So we'd like to change the plan. And yes, we designed this type like a Sigma. But in that case, the performance is same level as Sigma, but we can exceed it. So yeah, we stop and go to the next plan. So in this process, we understand the difficulties. Okay. At first, two designers try to make the new lens, but we found that this lens is very difficult. So after that, 5 designers try to design. And the difficulties are, of course, the optical performance and to get reliable space after the lens, and the weight. Because the SSM can control the lightweight lens, so we have to reduce the weight of the lens. And finally, the diameter of final lens. Yes, there are mount, so we have to make it small. And finally, we designed a lot of lenses. The moment you create a new lens, at first, this is one of the ideas, and we add the positive lens in front of the aperture stop. And the next, the first lens becomes weak, so we delete the first lens. After that, change in focusing. Before that, we used all of the lens movable for the focusing. But after that, we use the rear focusing to make the lightweight for the focusing. And after that, combining the 2 lenses here, these 2 lenses combined. Finally, we will make this lens as doublet. Okay. And so finally, we did it. Yeah, I'd like to show you the final. There are 5 groups and 8 lenses, and the front side and the rear side. And this lens is used in the rear focusing. Okay? And there are 2 spherical lenses. This one is to make large aperture f1.4, and the other one is to make the image frame flat. In many cases, the flatness of the image frame is not good. To improve the optical performance in the corner area, we introduced this spherical lens. Please see this slide. This slide shows the comparison chart between the competitors. Okay? please see here. Current model is not good in this area, but this lens has high contrast in the medium area. And in the corner area, we can make it good, okay, compared to the these lenses. We think that the new corner has a high contrast in the corner area, so please use this lens at open aperture. And this graph shows in the website. Okay. So I'd like to explain the dust and moisture resistance. There are normally to guard the front side, and the low wooden fabric cross as used around the focusing lens and autofocus and the manual focus switch. Okay, I'd like to show you the sample images. Sometimes a professional is taken, but image, but sometimes I took some sample images. So how to say, today, yesterday and today, many professional photographers showed a good image, but yeah, I'm just amateur photographer, so please forgive. Okay. Yes, but this picture is taken by a professional. Okay. And please see the here. Yes, it can. Let's see. The image is very, very clear and high resolution. Yes, I think you can easily see the fine details. This lens has very high contrast and resolution. Next slide. Okay, please see the center of the image. Okay. The very silent and fast focus functions fascinate you to take more photos. Okay, and this picture is just, here's my colleague. Yes. So yeah, there are very high contrast image. I think that I recommend you to shoot photos at open aperture. Okay. And this picture is taken by me, unfortunately. And this is the Tokyo station. Okay, please see the detail of the image. This lens can create high resolution images. Okay, but left image shows the center of the image at f1.4, and the right one is f2.8. And I think that the detail of the image is good at f2.8. So you can get perfect image from the f2.8 to f8. Finally, I'd like to show you the nice shot. Okay? Center image is like this. And the comma area. In many cases, there are comma aberrations. But in this case, there are small aberrations in the comma area. But I think that this is well collected. Yes, so I think that the two aspherical lenses contribute to improve comma aberration in the comma area. Okay. Finally, this is, okay, in this image, I find that there are photographer in this eye. So this lens can create a good image. Okay? Okay. So I'd like to move on next lens. This lens is 70 to 400 millimeter G2. Okay. Many specification is the same as the G1, but the color of the lens is white. This is a very big different point. Okay. This slide shows the lens configurations. There are two ED glasses to suppress the chromatic aberration at 400 millimeter. There are 6 group zoom type. Okay, 1, 2, 3, 4, 5, 6. 6 groups are movable for the zooming. And this group is a focusing group. And here is a nano air coating. Next slide shows the empty parts. And actually, the optical design is the same as G1. So MTF parts is the same as the G1. But this lens has a nano air coating. Okay? Left image shows a non-coating. Okay? And this one shows the conventional coating. And this one shows the nano air coating. Okay? Please see the reflection ratio. It's very important. In many cases, 1% of the light flux is reflected. So it becomes ghost or flare. But in this case, very small reflection. So this lens can create no ghost and no flare images. This slide shows the comparison chart compared to our competitors. Okay, nanocrystal coat, SWC coat, and nano air coating. Okay, we made it in our factory in Aichi Prefecture, and how to make it is different between compared to these coatings. And this slide shows the sample image of the effect of the nano air coating. You can see the ghost of this light, but the intention of the ghost is low level. Okay? And the flare around the light is increased. So I think that the nano air coating is good at any situation to decrease the flare and the ghost. This slide shows the faster objective tracking performance. We have 3 improvement points. One of them is the renewal of USI drive circuit. Okay. And so we can faster and more accurate focusing is achieved. Okay. The second is adding new command to communicate with lens and body. So the communication speed becomes 20 times compared to the old one. So we can make it faster. Finally, the new position sensor in SSN. So the resolution of the position sensor is improved by using the new sensor. So finally, the new lens offers 4 times faster object tracking performance. So you can easily focus on the object quickly. This slide shows the sample images. yeah, you can get the clearest image thanks to the number coating. This image shows the fast focusing. Yes, movable object is stopped like this. So you can easily focus on the moving object thanks to the new electrical circuit. Next slide shows the bird. You can easily take a well-composed photo, okay, thanks to quick response focus. This slide also shows the bird. Okay. Yeah. 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 And actually, there are things to protect his bounce, okay? Because this bird is, how to say, to take a photography. So, yeah, I think that this table shows, how to say, this lens can create a good, very, very good image. Okay, finally, this picture is taken by me. And the focal length is a full 100mm, but you can easily use it for the portrait. Okay, so I think that this lens can create a very, very high contrast with a high resolution. So please use this lens as a portrait lens. Okay. Okay. That's all for me. Okay. And now, thank you very much for listening. And I'm confident that we will make more lenses in the future. And please wait for a while. Okay. Thank you very much.
Thank you. For sharing with us your expertise, and helping us understand better the science behind the development of cutting-edge lenses and introducing to us the latest lenses from Sony. Obviously, you have a lot of fans here because of your work. They get to take the pictures that they are taking now. And Sony lenses Ichiban. That's what I could say. Yeah. Okay. I'm sure you have questions for Otake-san. So again, yes, over there. The first one over there, and then we'll bring this gentleman over here microphone afterwards.
Mr. Otake, first and foremost, thank you for creating so many good lenses for us to play. Just wondering, because the announcer said that we can ask that what are the lenses that we hope to get, we wanted to get. Is there any chance of Sony to make a 100mm f2 prime lens?
Please let me know the focal length.
Focal length is 100 mm.
100, okay. 100 f2.
f2.
That sounds very nice. Yeah, I try to have it. Now, actually, I don't have any plan to make the 100 f2, but yeah, how to say? Yeah, that sounds very nice, and I will talk with the product planning team. Okay, thank you.
Thank you.
Okay, then over here we have the gentleman with a question, and then we'll come back to this gentleman.
Hi, I have the STF, the 135 f2.8 with a transmission of 4.5. So I was wondering if you could make STF which is based on a 1.4 lens, then maybe the T will become 2.2. Like 85 1.4 becomes an 85 T 2.2, which would be very nice.
yeah. It's a very difficult question. Yeah. To design a HDF lens is very, very difficult. As you know, the dropping of the exposure in the corner area. But in many cases, it has a vignetting by the lens diameter. But for the SDF lens, there are no vignetting by the lens. So, how to say, F2 ray flux go to the corner area. So, it can create a good background black. But it's very difficult to make it large aperture. Okay, I understand your request, but yeah, it's, how to say, it becomes a very, very difficult my homework. Okay, thank you very much.
Thank you.
I understand that there's a new G lens for X, zoom lens. And so can you share with us like what is the focal length that you are doing and why?
Yeah, yeah. Yeah, I can say silence. Yeah, I can say silent voice, but I can say yeah. I can make an answer in this year, so please wait for a while.
We have another question from the gentleman who raised his hand at the back. Can you raise your hand again, please? We'll bring the microphone to you. Yes, over there.
Regarding about the 35 f1.4, recently the Sigma they come out
Sorry,
lens
I can't find you. I see, okay.
The 35 f1.4 recently the Sigma they come out their art lens and test out compared to the others L lens or Canon L. The quality become a bit so will it possible Sony come out any new Zeiss or G on the 35 f1.4?
Yeah, that's the answer. Okay, so please come to me after this session. Please.
Okay, just one last question. Did promise this gentleman over there.
Hi, good afternoon. Currently, we have this 6080 f2.5 Sony. Is there any plan or possibility to make this lens better? Like, for example, 6080 f2.8 lenses or something like that?
Can I confirm the focal length? Yes. 16. Okay, okay. Wow. Yeah, yeah. Oh, 16 millimeter. 80. I see. Okay. And then f2.8 is the yeah, 2 years ago, we make a 16 to 50 millimeter f2.8 lens. But how to say, it becomes a very, very big size. So, how to say that if we make it 16 to 80 with f2.8, in that case, it becomes very bulky size. Is it okay for you? future, I'd like to make it, but now I don't have any good answer. So please forgive me and please give me time to think of it. Thank you very much.
どうもありがとうございました。Mr. Motoki Otake from Sony Japan, ladies and gentlemen, thank you for your questions as well. I'm sure after today, Pakistan and his team will be working even harder to develop more cutting-edge lenses from Sony for all of you consumers out there. All right, thank you once again. Thank you. All right, ladies and gentlemen, if you'd like to try your hand at action photography,